This next tutorial will be a basic introduction to symbolizing layers. So in a previous tutorial we took census tracts and then we joined population data. So now for 384 census tracts we can see population, age, some things to do with occupancy, demographics based on race. And while this video was off, I actually went into and made some new fields. The reason for that will become certain in a moment, about whether or not a category had more owners or renters, and whether it was more white residents or black residents. So symbology is kind of the step that both precedes and then follows analysis. So it can precede sometimes if you want to do analysis but you're not sure what yet. You can use symbology to color and size your map by some attribute. So in this instance, we know where each census tract is in Philadelphia, and we're going to color them up by their demographic indicators. Follows after analysis, after you've done some analysis and you have your results appended to the attribute table. Perhaps you want to show those results to your audience. So symbology, it's always taking the shape, whether that's a point, line, or polygon, and it is depicting an attribute value for each shape. Depicting the attribute value for each shape with some kind of color or size or theme. So you access by going to Properties, Symbology. So there's 5 primary categories. This tutorial will really focus on the first 3, and then a later tutorial will focus on charts and multiple attributes. So a feature, single symbol, right? If I wanted to change it and make everything green, I would make everything green. The reason everything is completely green there is because I put no outline color. Rather, even though I have an outline color, I made the width 0. If I increased it back up to 1, I'd see the boundaries between everything again. The same would be true for points, lines, and polygons. You'll have the option to do a fill color and a line color. I can edit the line on the outside. Sorry if you didn't see that. I went to Edit Symbol. Make it wider here. I can change the way an outline looks. Perhaps make it like a dotted contour. Not great, that's pretty hideous. Not great control like you would see in other things, but you have some control over what your shapes look like. All right, let's make it go back to something a little more friendly. Do rows. Great. The next category, that's embarrassing. The next category is categories. So categories can depict some attribute value. Now it can depict both text and it can depict numbers. You know, like for example, I could do median age and I could add a value and I could just say any census tract where the median age is 25. I'm just going to do 25, make that green. All other values are going to be red. Who knows if they'll even be 1. And there you go. Those are the tracts that happen to have 25. Notice my layer on the side always will corroborate with the symbology that I've picked for my map. And if I were to create a legend, this is what I would see. So usually I like to use categories when you're trying to depict text-based values. So in this instance, category, what I've done is I've broken things up by whether or not they had majority owner-occupied housing units, so that's homes that are owned by people, or renter-occupied units. So homes that are occupied not by the owner but by some renter. So in that instance, I could find category. And here I could add all values, right? 1, 2, each independently, but I really know I want both, so I'll make all values. Let's say owners, they're going to be blue. Renters, they're going to be an orange. And now let's see what it would look like. Oh, let's just review real quick. Owner, renter. The label is how it will show up on the legend, right? So I could say owner, occupy, or owner occupancy is greater than renter occupancy. And here I would say renter occupancy is greater than owner occupancy. The count lets you know of the 384 census tracts that I have, 240 are owner-occupied, so at least more tracts have it. Now that doesn't necessarily mean that there are more owner-occupied units. Right? For all we know, each of these 144 tracts could have tons and tons of units. So I hit OK, and there we go. This is your map. Each census tract, looking at the number of owner-occupied units it has and the number of renter-occupied units, and depicting whichever one is greater based on a field value I had given it previously, own or rent. So anyone familiar with Philadelphia, this will make some sense to you. A lot of the owner-occupied housing tends to cluster here, up in the Northeast. A little bit into West Philly, it's kind of interesting, but you definitely see your renter occupancy dominating here in Center City, in Fairmount, up into a little bit of Northern Liberties, down here into West Philadelphia, and a mix of it in South Philadelphia. So another one, instead of category, I'll pick race. All right, so we'll make places where there are more black people blue, and places where there are more white people orange. And then we will do that, and now you start to see some really interesting spatial patterns. So for anyone who's looking to do an interesting form of research, Philadelphia, though being diverse, is a historically segregated city. Here in North Philadelphia has been historically, for the last 40, 50 years, predominantly black, and I mean predominantly. Here has been predominantly white and white. This section here, though it says white, it is technically white, but it's white or non-white Hispanic. So sometimes we think of Hispanic as being its own race, but Hispanic is actually an ethnic heritage, so it would not be in the same category as race. Center City, predominantly white. South Philadelphia, definitely, but Broad Street tends to be a huge divide, with everybody living east tends to be predominantly white, or it would be predominantly black over here. And then West Philadelphia. Now this map obviously doesn't show blacks, whites, Asian, Native American, the number of other myriad races there are. This is simply one where previously I asked each census tract to say if it has more black or white residents. So that's all that's being told right now. There are more black residents than white here. There are more white residents than black. So unique values, many fields, and match symbol to a style will be something we do in a more advanced symbology lesson. Color ramp would be in an instance, let's say we had more than just black and white, and we wanted to randomly assign them colors. Well, we could randomly assign them. Randomly assign. Randomly assign. It makes much more sense if I pick median age, add all values, and then I randomly assign them some colors. Now for median age, let's say, actually this is a good segue. If I did do this, there's nothing about this that is helpful. It's a patchwork of colors, and there's absolutely no order to this map whatsoever. There's no one color that is lower and another one meaning higher. If you gave this to a user, they would have no idea what you're talking about and would probably turn away from the map. Numerical data, such as median age, or the number of white residents, or the number of owner-occupied housing units, is best served in a category called quantities. So notice immediately when I look at quantities, or try to pick my field, I no longer have the option to do the category or the black-white, because they are text-based values. This will only work for numbers. So if I pick median age, ArcGIS will randomly give me some values. I hope every one of you is saying, well, how in the heck did they pick those values? Because it is critically important. And here is where people can lie with maps very, very easily. What you're looking at here is a histogram. To remind you of your statistical days, a histogram takes the values, right? So in this instance, the values are the ages, and breaks them into buckets. Right, so categories. We know that the ages are ranging from 0 to 82. Right, we looked at all 384. Found a minimum of 0 and a maximum of 82, mean of 35, median of 34, a standard deviation of 8. These should be familiar terms. What you're looking at with the histogram is, in the bucket of 21 or 22 or 23 or whatever, the Y value is the number of records. I say records so that you know this applies to any kind of table or shapefile you do. What record means here is census tracts. So the number of census tracts that have that category. So this is how you can understand that the median tends to hover around 34, right? 34 is not directly between 82 and 0, but the weight of the population distribution centers around 34 and then tapers off in either direction. Now that's critically important. Let's do this in 2 ways. We're going to do median age. We're going to do it in 4 categories each. So we'll do median age with a natural break Jenks. I'm going to copy. I'm going to paste. I'm going to paste. I'm going to call you natural breaks. I'm going to call you equal interval. And I'm going to call you quantile. So I go to equal intervals, same thing, except in the method, I'm going to choose equal. So now it has spaced them out at equal or close as possible to equal intervals from one another. And finally, I'm going to do, get into the classify, I'm going to pick quantile. We are going to come back and discuss what this means in greater depth after I show you why this is almost always the choice you should have when depicting ranges of numbers in symbology. So equal interval, if I were to look at this map generated by somebody, I would say, oh my goodness, well, most census tracts tend to be around the age 22 to 41, and that's true. But this color immediately leads me to believe, right, because the 22 to 41 is in the lower spectrum of things, that people are relatively young. Now, we know that 34 is the median age, so that's true. But what if I colored it like this? Now we suddenly get some greater variety because the range has changed. Now I've allowed the brown color to be anything from 47 to 82, whereas here it was only 63 to 82. And finally, I pick quantiles. Quantiles, 0 to 30 is the bottom range, whereas here it was 0 to 21, 0 to 25. Then it was 31 to 34. Look at the difference and how interesting that is. The range under equal intervals, which I'm about to turn on, was about 19. The range under natural breaks was about 9. The range here is 3, and yet there are still a great number of them. And this returns back to the population distribution. 1, 2, 3, 4 buckets, broken at 4 different values, whereas equal interval, the Y value, the X value, is equal within each of these buckets, or as close to equal as possible, 20, 21, 20, 20. Regardless of how many census tracts fall within each. Quantile, these may be much smaller value breaks on the X, but the number of Y values, or in this instance, number of census tract, number of records, is equal under each. So between 0 and 30, ages 0 and 30, an equal number of census tracts have a median age that's less than 30, then or it's equal to the number of census tracts that have an age between 30 and 34. It's equal to the number of census tracts that's between 34 and 39, and that's equal to the number of census tracts that have a median age between 39 and 82. This is a statistically accurate way of scaling your symbology such that it is representative of the total population. And this doesn't matter. You can make as many classes as you want. Notice I keep making the classes. Right, they get smaller and smaller, but still this huge range at the end remains so much larger on the x-axis than everything, because to get from 54 to 82, there's just not that many census tracts that have that as a median average. So it has to increase the value to be able to get the same number that might be in 33 and 34. So why they're called quantiles, right? A quantile, you might remember this back from your SAT days, remember, just took the total population, in this instance, the number of census tracts, 384, and broke it into fourths, fifths, tenths, 20ths, and so on and so on. The final way of scoring things here is you could do it manually as well. But interestingly enough, when you do it manual, you can't choose the number of classes. So sometimes you choose the number of classes before, like equal interval, and maybe you want to make things your own. Maybe you're interested in seeing under 25, then you care about 25 to 30, then you care about 30 to 50, and so on. You have the full ability to do that. Just be cautious that you can very easily lie when you make your own things up, right? So I'll make the argument here 30, and then I'll make this 35, or I'll even make this 30, and I'll make this 20. Seems like that might be reasonable. And then I would show this to people, and because there are very few that are the light brown and yellow color, I would say Philadelphia is an old city. Or at least that's what the eye of somebody looking at this is saying, because they're immediately looking at the dark colors and seeing more of them. So again, when using symbologies, be very careful about the numbers you choose for quantiles. Graduated symbols, proportional symbols, and dot densities are other ways to scale by numbers, and those will follow in the advanced symbology.